So today we will be talking about one very important concept in Python, which is called generator pattern. Um, it is it is the fundamental concept for both software engineers and also for um, data scientists. Usually, for everyone who is trying to handle large amount of data that is being generated from a function, and your system is not able to handle that much of data. So whenever you have this kind of situation, you in most of the programming languages previously, you didn't have any other way to handle that. So now, with the advent of some of the new modern operating system concepts and modern uh, programming language concepts, Python came up with something called a generator. Using that, you can actually create a nice uh, generative pattern of the function or of the data which is being required um, during the runtime. The key idea. So let me just write something about the key idea. The key idea is that we never need more than one data point uh, while processing. So this is because in usual scenarios, when you're trying to deal with a lot of data, we usually do not need more than one data point, and all of the processing that we are doing is on that single data point. So we do not need more than one data point. So let me give you an example, if you like. So let's say that I have a function saying multiply, and it takes one input, the value of the, let's say, a number. So let's say f for saying factor, or let's say factor, and it's an integer parameter, and it returns a list basically. So it returns a list of different ints, or let's say, let's not mention the integer return type. Okay, so what we are doing is, we would like to we would like to call this function um, multiply multiply like this. So we would like to call it like 2, and it will return you an array of uh, okay. So I think I also need to pass n, which is also another integer. So they take two values, 100 and 2. So okay, so what it does is basically it returns you, so whatever value you have, like 1, 2, 3, 4, 5, 6, 7, 8, dot 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 up to 100. It multiplies each number with 2, and returns you the multiplied version of that same list, which means it will return you um, 2, 4, 6, 8, 10, dot 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 200, if I'm not wrong, right? This will return you this. So let's say that we want to create that list, we want to create that function. How you do that? Okay, it's very easy. I mean, we just simply do for I in the range of whatever the number is n, um, n, and then we just simply take a list. We take a list, and then we just simply append the multiplied version of it. So we just do ret dot append, and then we just do I into 2, I into factor, right? This is something we do. And if we don't want to include 0, so we can start it from 1, and we can include the last element. We can do this, all these things, right? And once you do this, at the end of the function um, we return the red. That's it, right? And we can just capture the return value here, and we can print the all the return value in this. So we can do this, right? And what happens is basically it goes there, does all the processing, creates a return array, and then it passes the return array out of the function, and then you just print that array. So okay, so if you run this, yeah, so you can see it actually prints from 2 to 200, which is, you can see, if you just take 2 out of this whole array, it is basically 1 to 100. So it is 1 to 100, but each of the element is multiplied with 2. You can also pass a different value. You can also do, okay, there I want to do 2.3. I want to multiply 2.3. I want to multiply every number with 2.3 and then do the whole thing. If you do this, um, and you can see, yeah, it's multiplied with 2.3, so you get this array. So hopefully, so this is something which will work, and which will work as elegantly. I mean, you can write this function more elegantly in Python, which is called the Pythonic way, people call it. So what we do is, you can just do this also. um, you can do I into factor for I in the range of um, 2 to, sorry, to 1 to n plus 1. Yeah, I mean, you can do that also. This will also work. This is something we call it list comprehension, if you know about it. I mean, you can just pass a different value. Let's say I pass 4 and I pass 50 values, and I run it, and you can see, uh, once I run it, you get the whole thing done, right? It's 4, 8, 12. All of them are multiple of 4. Definitely, because you're multiplying 4 with it, there has to be some multiple of 4. So so far so good. I mean, this function is absolutely good, absolutely awesome, but there is a problem with this function. The problem is that what happens if you give this, like, okay, first of all, let me just run it from terminal, because that's another thing that people usually need to know. So um, let's say that I just need to move to this directory. Excuse me for a minute. Okay, copy path, and I just go to this path, and let me just zoom in so that I can see better. Hopefully it is big enough. So now if you do Python reader.py, and you can see it is printing all the list. It's printing all the elements in the list. So this is good. This is fine. Uh, let's say that your program logic is even bigger. I mean, you need to process. You need to process further on each element of the list, right? Process further on each element of the list, which is basically the return value here. I mean, basically we're trying to process uh, um, further some business logic or something else on this return values. So for us, it is only print statement, but for reality it can be anything else and anything else. I mean, you can just do summing up the numbers, you can do anything else, I mean, or whatever. But the main objective is that you do further processing after this. So having said that, you know let's just try to try to do some modifications in the function. Let's just try to import the sys, and just take the argument. So sys argv of 1, and then sys argv of 2. Let's say you do this. So what you can do now, you can just run it like this. So Python reader.py, and then you can do, I need 20 elements, each multiplied by 3. So I can okay, so sys argv actually takes string, so you need to convert them into integer. So you convert that into an integer, and okay, so that's it. And yeah, if you sorry for the hiccup, bros. Um, so if you do this, and voila, it prints. And you can change these values during the runtime. You should say that, okay, I need every element will be multiplied by minus 1.2, and I need 10 such elements. So give me the values. Uh, okay, guys. So what was that? I guess we were passing floating point numbers, but we're typecasting it into integer, which was not allowed, of course. So just for the sake of it doesn't matter whatever we're just trying to show here. For that, we don't need to have floating point numbers. Uh, we can just do it easily with integers also. So let's say we just need okay, so 43 values each multiplied with 9, we get the same thing. Now there is a problem. There's a problem with this whole logic. So let's just delete this so you don't need us anymore. Yeah. So there's a problem with this whole language. So to explain to you what was the problem, let me just create another tab in my terminal. And so there is a command in Linux-based operating system called htop. You can download htop um, using brew, or in Mac you can also use sudo apt-get or any other Linux command, and you can just look into the web what is htop and all. For Windows users, I guess you just have to rely on whatever Windows Microsoft provides. So what it does is basically it actually shows you how much RAM you have. In this case, it is 16 gig. How much RAM you have filled with, which is 9 gig here. Um, and these are the 12 cores. This is a 12 core MacBook. So it shows you that I know how many cores are occupied right now while processing. So let me just do a little bit of experiment with this. What about if I run the same program with 400,000 values? It's 400,000 values. So in Python 3.7, you can also do this. It's not a big deal. So let's say I just want every element to be multiplied with 9, and I just need it for 400,000 values. And I also need okay, by the way, guys, if you just need to know how much time a function that you are trying to run is taking, or how much time a command that you are using is taking, so you just do time um, and space the command name, and it will give you exactly how much time it took. It took me around 0.01 seconds to execute the whole code with 87% CPU usage. Okay, so let's say that I want to do the same thing, but now with 400,000 values. So uh, what will be the time taken for this? Okay, so now see, it is increased. Okay, it increased to 0.11 second. Previously it was what? It was sorry. Okay, let me just comment this print statement because it is polluting our environment. So yeah, so now if you run for the 41, it is around 0.3 seconds, and if you just do 400,001, it is around 0.7 seconds. Okay, let's just keep moving. Okay, let's increase this number by 100 times. Okay, so it's now 440 million, I guess. So now if you run this, it is taking some time. See, the prompt is still working. It is still not coming, and yeah, the time is 4.17 seconds. That means that the user, if I do it again, uh, the user is again 4.20. It's almost the same, so that means the user is not able to do anything for this much of time. Okay, and if you see, the CPU usage is also 92% or 95% is 92% for 40 data points, 95% for 400,000 data points, and a whopping 99% for 40 million data points. Okay, let's just run the code and see how the htop performs. Okay, let's just run it and then see htop, and you can see the spike. You can see the GBs are increasing, and now it decreased again, so probably it has worked it. So which means that whenever you are running the code, your RAM is being consumed. To explain or to show you more prominently, let's just increase this number even more, 2 more zeros. Now what will happen? Now it is running, and you can see your RAMs are increasing: 9.43, 9.42, 9.35, 43, 30, and it is still not running. It is still running, it is still printing and still calculating that many data, and your CPU is also using. The CPU is also using all the cores. Here you have RAM usage, constant RAM usage of it, and you can see that still there is no output. Why? Because this number is pretty darn big, and your program. Let me tell you where your program is stuck. Your program is stuck probably in this line, because it is calculating this many iterations, and then multiplying each of the number with the factor. So your program is stuck here. Your program is trying to build this list, and till the time it is built properly, your program will not return. And you can see it is still running. Wow. And you can see Python is using your swap memory. So for those who doesn't understand the operating system much, let me tell you that swap memory is a memory which is being used for temporary purposes. It is a memory which is used by your operating system. And you can see your swap memory is increasing, and it is not ending. I mean, it is almost 6 and 7 GB swap memory, and it is almost 6 GB filled, and it is increasing. Basically, whatever array is being produced in the intermediate step, it is being stored into swap memory. So you can see that your swap memory is now almost 8.42 GB. Now almost it is 100% swap full. So whenever your swap memory will be filled, your operating system will basically allocate more swap memory into this memory. So you're basically swap memory, how the swap memory works and how it allocates, how your operating system allocates swap memory. It's a matter of on a different video, so we will not talk about that. So let's just understand the basic concept. Your swap memory is very less firstly, and as you go along, your swap memory will be filled, and as you need more data, your swap memory will be filled. For example, here you can see that 15 GB is allocated. The moment it will cross 15, it will increase the limit. It will increase the limit to, let's say, 17 GB or something. See, the moment it hit 15 GB, 15.2, it became 16. So as you go along and increase the number of data, this number will also increase. This number will also increase. And so by now, I mean, your program, and by now your Python program has numbers which are humongously big. So think about that, guys. If your numbers are taking 18 GB to store, it means that it has to be really huge numbers, huge big numbers. Now, this whole idea, or this whole outcome that you are seeing right now, it will not be same for all the operating system. Probably in some other operating system, the swap memory will not be used, and you will use the RAM, exact RAM itself. So it is all depends on the RAM, or it all depends on the rather the operating system and how it handles the usage of the memory or memory requirement. But as you can see, as your data, as your program needs more data, your swap memory is being increased. But this will also have its own limit, guys. I mean, for this system, your swap memory is being used. For other systems, your RAM will be used. But this will have all of both of them, both swap and RAM, they will have its limit. At one point of time, your program will say, hey, I do not have any more space to allocate that much of data. And you know very well, especially for the data scientists, that today, I mean, this is the age of growth of data, and if you don't have much space in your computer, you're not good enough. So you need to have a huge amount of data and huge amount of capability in your machine also to process that much of data. And you can see that your program is not smart enough or good enough to actually multiply, even if it's a very simple program, right? You just simply multiplying I guess 9 with every number and just returning that list. It's the most simple program that it can ever be, but you are still not able to perform the task because it is taking too much of data. And because of sheer amount of data, it actually increased. So now you can see, guys, it suddenly decreased to 679 MB, and the swap memory is also decreased to 2 GB. So which means I am guessing that my program has finished calculating numbers for the data. So if I go there, and yes, it did finish calculating all the data. So if you see, it took around 256 seconds, too much time, too much time. uh, and it also take huge amount of almost 24 gigabyte of RAM, which was not possible to maintain and manage every time. So what is the solution, guys? So the solution is that Python comes up with something called uh, you know generator or generator pattern. So it based on the idea that, like, we never need more than one data point while processing. So the idea is that here we are just trying to print the whole thing, um, uh, print the numbers. But let's say that we are doing some more heavy intensive task, like we are just trying to loop over all the element in the return and just trying to print each element, okay? Or maybe just trying to do nothing. I mean, trying to just simply uh, do nothing. I mean, just trying to do some operation um, with each element. So let's write some heavy operations with each, right? So here, if I run this code, if I run using this particular, okay, so sorry guys, it is actually killed. The process is killed by the computer operating system, and the signal is 2. So if you do kill minus L, uh, so you can see it is killed by signal number 2, which is a quit. So it's a sig quit signal. It is a sig quit signal. So this signal is actually being used to kill the process, probably because why? Because it is taking too much of RAM or too much of memory, and now it is not possible to continue anymore. And this is what you usually see most of the time. And most of the time you see that your program is not able to handle that much of data, handle that much of processing. So what you do is you use something called generator pattern to create data during the runtime. What does it mean by during the runtime? Well, during the runtime means that you know that you need So see this program carefully, guys. Here you are just trying to take the red value and process each element on the red value. Let's say let's say that this is the return value. Okay, so you're just trying to process on 4 and then 8 and then 12 and then 16. So you are processing on each element one by one. You are not processing on all of the element together. So the idea is that what about if you can somehow use or generate these values when and where while we need this? Is based on a simple principle that if you don't need it, don't generate that. I mean, you are trying to generate all the values and then use those values into the list. That means till the time all the values are generated, you need to wait and watch, do nothing. That is actually waste of a lot of time. So what about this is that people actually, so let me give you let me just run this code again and show it to you. Okay, so let me just print um, okay, so let me just print the each, right? And if you print this and if you just run it, and you can see you don't have any input. Why? Because you haven't still haven't processed this ret yet. So it is still stuck here, which is here. Basically it is being called, this function is being called, and this line is being executed still. The moment it will finish executing, it will return those values, and then you will take those values and then you start printing. So it's a long time process, and also with the hope that your operating system will not kill the process. If it kills the process, then you are good for nothing, and basically you cannot use that data anymore. So the idea is that how about, so okay, so let me just stop the thing. So let me just kill the process, sigterm. Okay. So idea is that how about um, we can, because we never need each data, all the data at the same time. We need each data one by one by one. So how about if we can create those data one by one and then use them when and only when we need those data. So that there is something called generator which actually generates. So let's just create a function multiply gen, and the same thing, it takes an integer value n, sorry, it takes an n and it takes a factor. Okay, so n is I guess of integer type and the factor is again of integer type, and then now you just do for I in the range of 2 to 1 to n plus 1. Now instead of storing them, what we are basically doing, think about it guys, if you remember this code, the previous version of this code was like this. So ret and then for I in the range of 2 to 1 to n, ret dot append I into factor ret return ret, right? This was the previous version. So now what we are basically doing is you're processing each value and putting into the red until you complete all the ranges, until you complete this range function, and until your program comes out of this for loop. Here you won't do this, you just do yi yield. Yield is a keyword which is used to create generators in Python. So you simply use I into factor. That's it. And now let me just comment this out. Let me just call the multiply underscore gen and the same parameters that I used. Okay, if I do this, and now let me just comment this out, and let me just print the return. Okay, let me just print the return. Let's see what happens if I print the return only up to this. If I run this, and you see it did not return you values. Oh, what's wrong? And it returned you all of these things in just 0.03 seconds. And it did not return you values, it returned you a generator object. This is not something list, this is actually a generator object. Now you need to manually loop over the generator objects and generate values during the runtime. So now what you need to do is you need to use for loop as we just used here, and then print each values. Okay, and now if you run this, so remember what happened previously. Remember what happened previously when we used multiply gen. If you run the same code, it will not give you any values. Why? Because it is still processing. It is still processing all the data, and until the time it processes all the data, it will not return you any values. Unfortunately, it cannot return you all the values, right? But now, if I replace this code with multiply gen and then run it, just see what happens, guys. Wow, what happened? It just started returning all the values. And it also, I'm able to kill the process. Let me just do it again, guys. Let me just do it again. And let's just go and see the memory usage. It is barely increasing. It is still 440 MB. And the RAM is still almost same, not increasing at all. What is happening? Well, what is happening is because the Python is not pre-computing all the values in the list and then returning it. It is computing it as and when we need those values. So this is actually a very powerful concept. If you think it carefully, you can actually use it for a lot of purposes. For example, in our next session, we will see that we have a CSV file. So let me just move to the CSV file, and let me just do an LSL. And you can see this is a CSV file, and this CSV file is almost, I guess, okay, I cannot see the size, so let me just do a little bit of, so you can see this CSV file is almost 9.8 gigabytes. It's very huge file. It's almost 10 gigabyte of file, and then if you see it's a CSV file, 10 gigabyte. You cannot open it using any software. You just have to only parse the data using Python code. Now we all know that in pandas, for example, if you use Python and if you import pandas is a library, by the way, to load CSV data. So as pd, and you just do pd.read_csv, and you can pass the CSV file, and if you do that, your program will break because it is almost 10 GB CSV file, and if you try to load that CSV file, your program will break definitely. So let me just not go into pandas. There is a library called CSV. Using that, you can actually read a CSV file. But the problem with all of this CSV or pandas library is that they cannot give you, or they're created to give you all the data in the CSV file at once. They're not created to give you when you need this, right? So in the next session, what we will do is we will try to use both pandas and CSV to load a CSV file which is huge. And when we need this, well, let's say you are trying to solve a regression problem, okay? And in that regression problem, you see this CSV data set is given, and you do not have that much of RAM in your system to load that big CSV. How you will do the whole computation, how you will do data science, how you will do even machine learning and all the things that you can do with the data. You cannot do it, right? So you need to have something which actually loads a huge file in much more optimized way. So decorator and generators, these are the two wings, and generators is basically one of the wing which takes care of all the computation. These are basically called ad hoc computation. And when you need the data, then only fetch the data. Don't fetch it beforehand. This is very simple logic, guys. But you know, I just thought I should tell you, because before I start moving into something really deep, something really big, hopefully it cleared you. Till the next time, see you guys. Happy coding.